Welcome class, my name is Mr. Brock. I'll be your professor today along with
me, Professor Salon, PhD in chemical physics.
And me, Professor Luke.
I can see you're all very excited to be here today.
Does anybody know anything about covalent bonding?
Something about electronegativity, right?
Electronegativity, the ability of an element to attract electrons within a covalent bond.
Is there any way for an atom to be more electronegative?
Yes, if an atom is more electronegative than another atom, it will pull the electrons toward itself and away from the other atom, creating a separation of charge called a dipole moment. This means that there's a positive end and a negative end.
There are different bond types, right? How do you determine the type of bond?
There are 3 ways to determine a type of bond, young apprentice. Determine the differences in electronegativity values for 2 atoms of the bond. Correlate the En difference to the type of bond according to the bond type. And the greater the difference in electronegativity values, the greater the ionic character of the bond.
Elaborating on what Professor and PhD Salon was saying, there are 3 types of, there are 3 bond types. There's covalent, which electrons are shared equally between bonded atoms. There are polar covalent, which electrons are shared unequally between bonded atoms. They're ionic, which are electrons are transferred from the metal atom to the non-metal atom. Okay.
Through this chart, you may determine the difference in electronegativity and the type of bond.
An example, hydrogen and bromine. So you'd have H and Br. H being 2.1, Br being 3.0. All you would do is you subtract it, so it'd be 2.1 minus 3.0, which equals 0.9. And as you can see on the difference in electronegativity chart, it would be polar covalent because it is between 0.4 and 2.0.
You hooked up with Dylan. Did you guys they trying to do anything else?
All right. So this PhD speaking, trust me, PhD genius, just whatever. But atoms, they're not equal. If you have a lower atom, then it's going to be different from this. Basically, aluminum, let's take an example of aluminum. This is S plus because it's higher than actual bromide, right? Which this would be S minus, and then we would subtract these, find the value, and the value would determine if it was polar or non-polar. PhD speaking, not a calculator. And
Again, elaborating on what PhD Master Salon was saying, let's say you have aluminum, this would be 1.5. S plus because it's lower than bromine, which is 3.0, so this would be the S minus and this would be the S plus.
A molecular geometry is polar should it contain a lone pair, be asymmetrical, the dipoles cancel out, or if identical polar bonds cancel in a tetrahedral.
What are those arrows in molecular geometry?
well, I'm glad you asked, young incompetent student. PhD here. Hi, welcome to Chili's. So, remember in my last lesson 3 seconds ago where I talked about S plus and S minus? Well, the S plus, for example, is the arrow here, C, which is carbon. Now, the arrows pointing away from it are going to the S minus. So different polarization. And that determines what the arrows are. And that is molecular geometry. PhD, practical herbal department. You're welcome, signing out.
And that concludes our lesson on covalent bonding. Thank you.